So this is a quick example given a very simple circuit, and they're asking us to calculate the total resistance seen by the source. Of course, this is the source here. So what that means then is if we were to have terminals here and here and detach that source and looked into the circuit from that direction, if we were to place a meter on these two terminals, what resistance would the ohm meter register? So let's look at how we do that. So as we said, let's think of this as that this is not attached here. And again, we're looking for between this point and this point, what is the equivalent resistance. So the first thing we see is we have this R2 6 ohm and this R3 12 ohm in parallel with each other. And so to calculate that, that we can replace that with one resistor. We'll call this R23. And so what that will be is R2 times R3 over R2 plus R3. And when we plug those values in, that'll be 6 times 12 over 6 plus 12, which will be 72 over 18. And we divide that out, and that becomes 4 ohms. So that means those two resistors could be replaced simply with just one resistor. So that being the case, we can eliminate all of this here and this value here. And so now what we have remaining, we're going to call this R23. Sorry, can't write my threes. R23, and it's a 4 ohm resistor. Okay, so now we only have two resistors left. That's R1 and R23, 6 ohm and 4 ohm, and we see that they are in series with each other. So then we can calculate the new resistor here, and we'll call it R123. That'll simply be R1 plus R23. They're in series. So that'll be 6 plus 4, and that's going to equal to 10 ohms. So that being the case, this is really our answer here. And so what that means then is that we can replace all of this as well. So now this will now be just a wire across there. And this new value here will be 10 ohms. That's what we're calling R123. So that is your total resistance seen by the source.